I am very interested in the problem of trying to predict human movement with the intent of eventually being able to predict human injury to then create mitigations beforehand in training to avoid such things from happening. And when I was reading a lot of paper to do literature review to choose the right thing, I found this really incredible one that was published in 2023 that analyzed the robustness of four different machine learning models. So convolutional neural networks, random forests, support vector machines, and Mars. However, even in the short 2 years that it has been since the creation of this paper, because Mars library was not kept up with, I was not able to use it. So I then only replicated the paper and analyzed or juxtaposed three different models, CNN, RF, SVMs. Now, when I initially started, I thought in my head that I had to create something entirely from scratch. So before parsing in any data, I created a synthetic human. I split my project up into two big phases. The first being the creation and establishment of the synthetic data pipeline. And then the second phase would be training, validation, comparison between what was synthetic, what was real, and then from there, I thought I would be able to introduce something new to predict something different. However, what I found in comparing the real world data and the synthetic data actually took this project in a different direction than I had intended. But I'll talk to that about that in a second. So I initially started by creating a synthetic subject and mimicked not only IMUs and their placement, but EMGs and their placements. And then because human data is very noisy, thought it would be smart to not only introduce noise to the system, but to introduce noise bursts to the system because sometimes that happens too. If you're working or running and something hits your leg or you hit something else, then you're not only getting extra noise of wind per se, you're also getting that extra jolt that is not so prolonged. And because I wanted to mimic real world, this made the most sense to me. So I tried to create the messiest, noisiest environment I possibly could, and then take a stream of randomized numbers that became data and then track them and then try to prove what Mohagdam et al. Proved, and that was that convolutional neural networks are the most computationally sound. They produce the least errors in accuracy or prediction accuracy, I should say. And I definitely did prove that. What became very interesting is that when I found his data sets on OpenSim and started to try to parse that information in based on the structure, the architecture I'd created, I learned that domain shifting was not as expected. And quite frankly, the biggest takeaway of this entire thing was that synthetically generated data cannot and should not be used or to replicate real world data. And this was very interesting to me because I feel like this is an obvious thing, but I also have heard quite a bit lately of the debate on should synthetic data be used? Is it a good idea when trying to validate a system? And they definitely validated everything I wanted to see and was expecting to see. But when it came time to actually replace what was synthetic with what was real, the numbers did not match at all. The numbers did not match at all. If you'd like to know more about what I did, if you'd like to read my report, if you'd like to see my code, definitely come to my virtual poster session, but you can actually scan that QR code and be able to read both of them. Thank you.